in fact, because wherever we are working, we need to understand what is the reason just behind that. So if you could see here, here I would like to explain you about history of SAS. It was developed in early 1960 at North Carolina State University. So actually this idea was conceived by a graduate student by the name Anthony Jaber. So he just built this software just for his management activities and as well as statistical activity of his agriculture field experiments. For that reason, initially he just started, he just used for his thesis work. At later point of time, this Anthony Jaber, he has collaborated with Jim Goodnight, and then at the moment when he collaborated with Goodnight, they have integrated few more, analytical features, kind of analysis of variance and as well as regression. Then the moment onwards, right, this software is going to be started using a widen horizon, and then the moment onwards, SAS is going to be used across multiple industries. Like if you see nowadays, SAS software is going to be used multiple environments. It's not only clinical. It can be used in pharma. It can be used, healthcare. It can be used in banking, and it can be used financial. It can be used, risk analytics or marketing risk. There are many of the environment or many of the domains that people they are start utilizing it, because this software usually meant for initially meant for a statistical, and later point of time they start understanding the beauty of the software, and they start using just for their data management activity, data reporting activity, and some people they can do kind of a predictive modeling. They can use this, and a basic kind of statistical or mathematical analytical kind of operation also they can perform with kind of software, with this software. So initially the people they used to call them, some people they can call as a software as a system, but if you can see the SAS, we can term them as a statistical analysis software, and we can pronounce them as a SAS. But now SAS is going to be fully controlled by SAS Institute by NAP Carey. It was existed in North Carolina. So if you can see here in my next slide, here I'm trying to giving an overview where and all we can use a SAS and what are all the things that we can perform with the SAS. If you can see SAS, it's a kind of an integrated system of a software which could enable all these facilities. If you can see SAS, there are areas where we can use with help of SAS kind of a data entry activities, retrieval and management activities. And some of the people they can purely use SAS as just for their report writing and as well as graphics design. And some of the people they can use SAS software just for statistical and mathematical analysis. And there are very few they can use SAS just for their business planning, forecasting and decision support. And a few more industries they can use SAS for their quality and operational research and project management. And very few organizations they can use kind of application development. So these are all the areas where SAS really fit in and fulfill their their problem. So if you see in among them majority of area where exactly that SAS can be utilized, one of the area I can call data management. So initial area where we can work out, and report writing and graphic design, this is the second area where we can prominently use SAS software in majority of the industries. And the final and foremost one I can call them statistical and mathematical analysis. So that is where SAS has proven software where majority of the people whenever they want to do any kind of analytical activity, then there is no alternative. It means like, there are many of their benefits when compared to the rest of the statistical tools. So that is the reason why if you can see any of the industries, if they want to make any kind of decision making or if they want to do any kind of statistical things, they can pretty well rely on this software. So that is the reason why these really many activities can be achieved or can be performed, by the software. Okay, and Whereas coming to, as I told you, right, if I want to kind of a data management, or if I want to kind of, data reporting, or if I want to kind of statistical analysis, so which is always related to, a data related activities. Because what exactly data? Because now everyone are much concentrated about big data. So in earlier we are very much concentrated about data warehousing concept. It means all about the entire, right? Everyone are revolving around the data. So what exactly we can do in a data, basically in a SAS. So if I want to understand what data it is, and so I need to perform, in any one of the organization, there are 4 tasks broadly can be categorized. The very first task I can call them as a data access. For example, might be in a system where we can come across many of the source systems. So for that reason, right, if I want to do any kind of management or reporting or whatever it is, first and foremost step it is, I need to access the data. It means my data might be residing, a kind of Oracle database, or else some kind of source systems like Access or Excel or a flat files or a kind of, mainframe environment. So whatever it is. So our foremost step is first we need establish a connection with a source system. So the moment once you establish a connection with the source system, so that we can easily access the data, with the SAS. So that is, I can call them, is a data access is a first and foremost step in majority of the data driven tasks. So then once a data can be accessed with our SAS utility, then we can start performing, kind of data management activity. So what exactly data management might be the reason, right? For example, you can see we used to get a data, for multiple source of systems. So if suppose in one system having one native of one in nature in look like, and whereas another system having its own native. If I want to make any kind of analysis, my data should be in single standard. I mean to say it was uniformity, so that if I want to perform any kind of analytical on top of this data, I can easily pretty well perform them. So that is the reason why in a data management activity, what I can do, I can pull the data from the different source of system. I can maintain single uniformity across the different sources. And the moment once a data management activity can be performed, then I can go for analyticals. So where exactly I can apply, kind of statistical procedures, and finally I can get to know what is the relationship which was residing within the data. So that is a where statistical, our data analytical portion came to picture. The moment once I get to know that what exactly the data and what could be the relation, I can understand. But to a layman or to a management, whatever the things, right? Basically, a statistician, they can very well and understand what exactly the data it is. But they are very poor, right? In predicting what exactly data, what values it is. So for them, right, whatever the results that we have seen, right, we are converting them, more of a representation, kind of more of reporting. So that is a way the people who are not good enough in the technical background, by seeing the reports or by seeing, um, the graphs and everything, they can very well understand what data it is. So that is a where broadly I can call them these kind of tasks. Data, yes. Welcome, Naveen. We just now started. So these are broadly kind of 4 major activities that we are always performing in area of data-driven tasks. If you can see here, how exactly we can bring a data. Just give me a quick minute. Naveen, could you please check your mic and speaker? Under audio, there are 2 options. One is telephone, and another one is mic and speaker. Could you please use mic and speaker? So if you can see how exactly we can, our major activity in any one of the environment. So we are always turning a data into more of information. So if you can see, right, around 80% of our majority of the activities, which was, more are related to data related activities. It might be a kind of a access. It means access, it is nothing but, data access, and another one is kind of a scrubbing, and then we can perform kind of a transformation, and finally we can manage. The moment once we can manage, then finally we are storing, and whenever we do want to retry, right, any point of time we can retrieve. So that is the reason why majority of in any environment we can always working on 80% because purely related to data activities. And if once my data is get ready, then I can start using my analytical activities or analytical kind of operations to understand what data it is. So that is a way my data I can easily convert into more of a information way. Now let's see how exactly we can get to know data into more of information in SAS. For example, here I'm trying to show you an example, more of a pictorial, but later point again I will show you in more in programmatical way. So if you can see here, right, in SAS, how exactly we can convert data into more of information. So as I discussed you, Naveen, could you please mute your headphones? Yeah. So how exactly we are performing over here, right? So as I told you, right, since we have a number of source systems, from a source systems, we can call them entire whatever the thing which was residing in the source system, we can call them as a data. So what exactly we can perform, in a SAS, whatever the data, right, whatever the data which was residing in a source system, with help of a data step or with help of a proc step, right, we can convert the total entire data into more of information. So this information can be utilized for a decision making or a better business operations. So if you see in between data or information, as I told you, there are two steps. One is a data step and one is a proc step. So as I told you, typically in SAS, we used to always, we are always going to write programmatic in a two ways. The very first one was a data step and second one is a proc step. What exactly we can perform with the help of a data step? So with help of a data step, what exactly I can do now? Either I can fetch the data if it is existing from external database or the external source system, and finally I can convert from this data step. I am going to creating a SAS data sets. So what exactly we are going to do in a SAS? With help of a data step, we are going to creating a SAS data sets. The moment once we created a SAS data sets, and finally we are using some kind of a procedure. So once upon I use a procedure, I can convert total my data into more of a meaningful way. So that is where I can call them as a information. So I will try to take you in an example, after a few minutes. Okay. So this is the way where we are converting, our data into more of information in a SAS. Now, coming to a design of a SAS software. Yes, I can call them. This software is a 90% independent of platform, but as well as similar to that, I can call them. This is a 10% is dependent. So it means like this software can be installed in any environment, either Windows or either Unix or Linux or mainframe, whatever it is. So that is a way majority here I can call them. This is a 90% independence as a platform, and whereas 10% as a platform dependent. So in similar way, SAS can be worked out in any environment or any operating system. And if you can see here in my next slide here, I'm trying to see, right, this is the multi-engine architecture. It means like, wherever your source system, might be your source system might be DB2 or a Teradata or a Sybase or Excel or a Oracle or a DBase or SAP, whatever your source system, SAS can easily, can easily access the data, and it can start its own desired operation as per the business demand. So that is a reason in such a way, right? SAS software has built, it was a multi-engine architecture where we can fetch the data from any environment. Okay, so this is a till now, and coming to as a SAS program. So before going to further slide, here I'm going to show you software, a SAS software. So you can see the software which I have opened you. This is a kind of a Windows software, Windows environment. This software was currently was installed in Windows platform. And if you can see software which was always, the symbol of software which was inverted triangle in shape. The moment once we open a SAS software, you are broadly seeing a kind of windows. One is the editorial window, the second one is a log window, and the third one is output window. And along with that, there is a one more window called Explorer window, where you can see the libraries, file shortcuts, and the favorite. And there is a one more window where you can see the result window. It means like, the moment once you can open SAS Windows environment, broadly you can able to access. There are 5 windows. Here I would like to tell one by one window and its functionality. So if you can see, this is the editorial window. First, I would like to tell you the importance of editorial window. The editorial window is a place where exactly we can write our, kind of SAS programming part. And the moment once you write any kind of programming part in this window, in the editorial window, so if you can execute this program, so it will compile. And during compilation, if my program either syntactically or either or logically, if it is kind of any issues, I can see all kind of notes or errors or warnings in my log window. So that is where log was defined it. Whereas output window, this is a window where I can see the output. I can see, for suppose I have executed my piece of code in my editorial window. I can track all my logs and everything in my log window. But where can I see my results? I can see my, my entire output I can see, in my output window. Okay. So, and whereas in Explorer window, whatever kind of programs which I have executed, which will go on residing, and finally it will save in the libraries. So library is a place, this is a repository where what are the programs which we have executed, right, which was stored in these libraries. So if you can see here, broadly you can see different kind of libraries. Work is a library, maths is a library, SAS helper, SAS user. These are all the different kind of libraries which SAS has developed. Okay. So if the user himself, some point in time, the user themselves, they want to create their own library for their business need. Yes. Well, even user himself can create his own library. Okay. And whereas the result window, as I told, whatever the program which I have executed, all kind of results will be can be viewed as a tree manner in my result window. So that is a way broadly, this is a SAS, navigation part. So coming back to my PowerPoint presentation. So as I told you, a SAS program, for example, as I told you, SAS software can be perform many of the activities. If I want to perform any kind of activity, I have to write a kind of program. So this language I can call SAS program language. This language I can call them fourth generation language. So broadly, a SAS programming, I can call them it's a sequence of steps. With that, I can, user can submit his own design kind of program, and the moment once you submit, it finally execute and finally it will return. It will, return out these kind of operations. So broadly, a SAS program consists of, 2 steps. The very one step I can call them, so data step. So if you see the data step, this was typically used to create a SAS data sets. So it means what exactly is SAS data sets? As I told you, so if I want to perform any kind of activity in a SAS software, so our first and foremost step, we need to access the data. So some point of time, my, my data might be existed in a source system, like a kind of a raw data source. So what exactly we can do? Some point of time, my data itself, some of the environment, right, where the people they will, give my data in a SAS native form, that is SAS data sets. So whatever it is, what exactly we can do in a SAS programming, our first and foremost step, we will access the data, and with help of a data set, and finally we are going to creating SAS data set. So the moment with help of a data set, we have created SAS data set, then afterwards, whatever kind of operation that I want to perform, some point in time my customer, they want to do only kind of, graphs, I can generate the graph. Some point in time my customer, they want to do kind of statistical operations, kind of a mean or a frequency or a univariate or whatever it is, I can perform kind of thing. Some point in time my customer, they want to do simple tables, just they wanted only tables, I can generate only tables on top of it. Some point on my customer, they want to, see kind of, they want to edit some kind of data which was available in my native data set. That is also we can perform it. It means like, the moment once I created a SAS data set with help of a data step, whatever desired operation that I can perform with help of a proc step. So that is the reason here I'm going to define proc steps are typically used to process their SAS data sets. That is, either we can generate the reports, or either we can generate the graphs, or else either we can edit the data, or else we can sort the data. Whatever it is, any kind of operation we can perform on top of the SAS data set, and then we can get our desired results. So that is the way we can convert the entire data with help of a data set. We are converting the entire data into SAS data set. So that is a where SAS can understand the entire data. If whatever the data that we are accessing, right, if the entire data will be available in a SAS data set, then and then only SAS can start perform it desired operations, and finally it is going to be see the reporting. Okay, so that is a where typically SAS program can be achieved. Now I'm going back into SAS software, and I would like to show simple SAS programming. So as I told you, typically SAS programming consists of two steps. One is a data step and as well as proc step. Okay. Before going that, I would like to tell you some more understanding. I hope everyone might understand, DBMS system. In a DBMS system, broadly we can call them RDMS, in relational database management system. We are always calling them, we are always storing the data in tables. Okay, how exactly we are storing that data in a tables like rows and columns? In a similar fashion, if you see in a SAS, how exactly we are storing our entire data, how exactly things we are storing, in a DBMS like a tables. In a SAS, we are storing entire data in a SAS data sets. Okay, so whereas in tables we are in a table the data was accommodated like rows and columns, but in the same way in a SAS data sets, how exactly the data can be accommodated. In a rows I can call them, in a SAS all the rows I can call them as observations. Okay, and whereas columns I can term them as variables. Okay, so if you see any kind of RDMS system, our first and foremost step, we are always creating a table. The moment when you are going to creating any table where we are going to specify what and all the rows and what and all the observation that we want to see that. So in the same way, if we want to create any SAS data set, as I told you, we always use to SAS data step. And once with help of a SAS data step, right, in a SAS, I can convert my data into SAS data sets. So once SAS data set is available, then I can perform my design different business need as per business requirement. So here I'm trying to show you I'm going to show you how exactly we can create a SAS data sets. So as I told you, if we are going to creating any SAS data sets, we are always use a data step. So now I'm going to show you how exactly we are going to creating SAS data step. So similar to the moment when you are going to creating any tables, right, in our DMS system, right, we are always naming for a table. So like in a similar fashion, the moment when we are going to creating any SAS data set in a SAS environment, we always give a name. We are always term the name. For example, here I'm going to creating a data set. I'm going to creating a SAS data set by the name class. For that, I'm always starting with a keyword like a call keyword by the name data followed by a class. So it means what exactly here I'm going to creating data step. Here I'm going to, so if I want to create any data step, I should always start with a keyword called data followed by data set name, and each and every line, right, it should be end up with a semicolon. So it means like here I'm going to create a data set by the name class. As I told you, if I want to create any SAS data set, I should always specify the observation and as well I should always specify the variables. So in this class data set, I want to specify a columns. So if I want to specify a columns for this data set, I should always use a statement called like input statement. So if you see in a class, broadly we can expect the student IDs and their age, okay, and their class as well. Okay, so it means like with help of input statement, I am going to declaring these are all the columns that I want to expected in my class data sets. And again, this statement should end up with a semicolon. And then, as I told you, I have defined a name for this data set, and then I have specified my columns names, nothing but here I have specified my variables names. Then my rest of the job is I need to specify my observation array rows. So if I want to specify any observation array rows in a SAS programming part, I should always use card statements. So I use specified card statement, then I start using my data. Student ID equal to 12 and his age equal to 23 and his class equal to 5th class. And the same, if you can see, my second student ID equal to 30 and his age is equal to 25 and his class equal to 6. Likewise, similar kind of data. So finally, I'm going to ending this step with a run statement. So run statement is, it's a kind of, statement, program terminator step. So if you can see here, right, what exactly I mean to say that here I have created a SAS data set by the name class. In this SAS data set, I have, 3 columns called student ID, his age and his class, and for them, these are all the columns. Sorry, for these are all the rows. In a sense, I can call them these are all observation. And finally, so it means like, and finally I have ended this program with a run statement. So the moment once I execute, I have created like this. I'm going to creating SAS dataset by the name. So if I want to execute, I have to select the total my program, and then here in my menu drop down, I have taken there is a running icon. The moment once I mouse over, you can see the submit, right? So first we have to select and then we have to submit. The moment once you submit, right, it's submitted. Then if you could open your log window, it will show you SAS dataset class and this input. Here it will show you work.class having pre-observation of 3 variables. It means like if suppose if I made any kind of any syntactical error, it will start showing errors of warning. But now it doesn't have any kind of syntactical error, so that is the reason I simply extract all the nodes of this my programming path. So it means typically if you can see, as I told you, whatever kind of programs which have created, which will go by defaultly, which will go on residing in my libraries. So if you can see by defaultly, the program will go and sits in my work library. So I just click on my work library where you can see SAS datasets as a work. So if you can select and if you can double click, right, whatever kind of data which I have given, right, the entire data which will be visible over here. Okay. So that is a way I have created a SAS data sets. So it means like, with help of a data set, I have created a SAS data set. So once my SAS data set is available, then with help of a proc step, as I discussed I want to only print my data. So that is the right reason why I'm using a procedure called like a print procedure, proc print data equal to, here I want to print my data set by the name class. So that is the reason here I'm going to specify proc print data equal to class, and then I'm going to run. So here I'm going to execute procedure called like a print procedure and then execute it. So the moment once you execute it, you can see the results in our output window. Subject ID is yes, and as well as a class. And as I told you, in result window you can start seeing all your native way. So likewise, here I have created a SAS data set, and then I start performing my desired operations. Like this is simple, proc print kind of activity which we have. If you can see, here I'm trying to show you some basic statistical procedure like a mean. So I want to perform, mean procedure. For that SAS build procedure it was available. For that proc means data equal to, I want to perform, a mean procedure on top of this data set, and then I'm going to execute run statement. Proc means data equal to class and then run. The moment once you execute run, it will start showing, for student ID. So it will show you what is the mean of all the student IDs, and it will show the mean, and it will show the standard deviation, what is the minimum value and what is the maximum value for all these variables. So that is the reason where you can see for a student ID you are able to see that, for his age you are able to see that, for a class you are able to see that. So that is the where by simply applying our statistical procedure which was inbuilt in the SAS software itself. Just what exactly, right? We need to understand which procedure that we have to use for our desired business need. If you know that, that is more than enough. So that is where I have created simple proc mean procedure. Then I will understand what data it is. Okay, that is where we can perform any kind of statistical, even frequency or even univariate, any kind of operation we can perform with help of procedures. So that is a way I can perform a simple simple prints. I can get to know that, and I can get to know the statistical perform things. I can get to know. Now let's see how exactly I can see the graphs. Proc G chart. Again, I want to see my graphs on top of my class data sets. So that is the reason I proc G chart followed by data set by the name class, and then we were for student ID, and then run statement as well, and then I'm executing. The moment once I executed that, it will start showing the results, frequency, like in more of a graphical. So some point in the customer, they want to understand what exactly it is. So for them, right, if I can show you these kind of statistical results, they won't understand what it is. So if it is more kind of graphical way, they can very well easy to understand. So for your better understanding what exactly, here I'm going to creating a pie chart. So in earlier I have created a horizon virtual board. Now I'm going to creating pie charts. Even with help of pie charts also, I can perform my desired operations. Likewise, I have a data which was the total data I have converted with help of a data set. I have converted in the SAS data set. The moment once a SAS data set is available, then I can perform my desired kind of operations. I can perform, simple listing reports I can generate. I can generate any kind of statistical reports I can generate it, and I can generate any kind of graphs or reports or whatever it is I can generate it. So that is a where I can perform any kind of operation with help of a SAS. Okay. So likewise with here I'm trying to give you a basic simple examples. This is a where majority of our environment we are always perform measure it up. These are the kind of activities. So going back to our presentation. So typically typically a SAS data set having two steps. As I told you, SAS program having a data step. So with help of a data step here, I have created a staff as a data set, and then I have created proc print procedure, and as well here I am performing a proc main. So these two steps I can call them the proc step, but whereas the initial and foremost step I can call them as a data step. So we need to understand the objective data step, right? With that I can easily create a SAS data set. It means like here I'm telling to the SAS saying that I'm going to creating a SAS data set by the name stop. In this data set, in this data set, I'm going to specify these are all the columns and these are all abbreviations. Likewise, a data step always, instructing to the SAS accordingly. SAS is going to be creating its SAS data sets. Okay, so now coming to step boundaries. As I told you, SAS always the SAS program always started with a data statement or else it's a proc statement, and it should always end up with a run statement. Measure our statements, right? We are always end our program with a run statement, or very few we are ending with a quit statement. Okay, so and as well as some of the programs, right? It might be start, it might be either a data step or a proc step. So if you can see here, right, how exactly we can understand what and all is data step boundaries. All SAS data keywords like a data run or a proc or run, whatever it is. So these and all things we can call them data step boundaries. So that is where I am trying to say you. These are all highlighted in green color. So if you can see even in a program also, right, whenever we are going to creating any kind of data SAS keywords, right, like a data or input or code statement, whatever it is, it always visible in our blue in color. So if suppose if I made any kind of mistake, if you can see, it will show you red in tone, red in color. So with that we can get to understand if you made any kind of mistake even by the time of writing our program, we can easily understand, because since the window which we are using that is a kind of enhanced window. Okay, so typically as I told you, SAS programming having data step. Okay, these are data step and this is the proc step. Always if you want to create any program, either it should always start either with the data as a keyword or as a proc keyword, and always any one of the program always end up with a run statement or a quit statement. But broadly majority of the times we are using run statement. Whenever we are using advanced SAS, that is where we are using proc SQL. So that is where we are using quit statement. And if you can see any one of the program, right, either it may start with a run or a proc. So that is where I am trying to show you, in my this slide. So that is one. Always start with a data statement or a proc statement, and always SAS, how exactly SAS can detect whether it was end of statement, whenever it will encounter run or a quit or beginning of another step, either a data or proc statement. So that is a way SAS can understand. And these are the things that broadly SAS can understand, starting and terminator. And this is typically, SAS look and feel in our Windows environment. And this is the way, we are executing. The moment if you are executing in mainframe environment, this is typically look and feel of your programming part. So the entire program, if you can see here, right, whatever the kind of program we are going to see, the normal Windows environment, similar to the same. But the thing is this, what is the difference? It is before writing our programming part, we have to write a JCL, appropriate JCL. JCL is stand for, job controlling language, which can perform our desired operations. So those things which we have to define the moment once we are executing any kind of program in Windows environment. And the moment once you submitted any kind of program, we can see, a kind of a log and as well as output. So in a log window where, as I told you, right, it will where we can track all kind of information like, processing of a SAS programming, include any kind of warnings or errors or anything else, we can see that. And whereas SAS output, it was typical, I can call them, our default, output where we can see in our output window. The moment once I executed any program, our log will look like this. This is a log window where we can track all kind of nodes, everything. And typically this is the output that we're going to see that in our, output window. And this is for our simple proc print, and this is our main of output. Okay, and likewise, so that is where if you see right here, I have executed SAS data step and then I have printed, I have means. So that is the way I have seen the results accordingly. Okay, so that is it from my end. Are there any questions? That's it here from my end.
Hello.
No, yes.
Myself.
Could you please tell me, man, who is this?
Naveen.
Yeah, yes, Naveen.
How long it will take to learn base SAS and advanced SAS?
Because within 30, yeah, within 30 days. You mean to say like our program is a 30 days, 30 hours program. Okay, we are organizing, daily 1 hour. Within the 30 days, you are you can get to know bases and as well as advanced SAS.
You will be able to cover all the topics, right?
Yes, yes. You can get to see our curriculum. What are the topics which we are going to covering, right? You will get to know our curriculum.
This is only through online mode?
Yes, only through the online.
So what is the fee structure and all?
Fee structure and all, right, our team can be discussed. Okay, so so you can reach out.
Today what you have done is recorded. Can you pass it on if it is so?